Okay, Johan, please move to the next slide, which should be Bear Valleys. Okay. And I believe Alexis Ravnik is the first to present from Bear Valley. Please go ahead and speak up.
Hello, I'm Alexis Ravnik, although Paul Marconi is going to give a brief introduction, was my understanding.
Oh, sure. Please go ahead, Paul.
Yeah, this is Bear Valley's 2026-2028 WMP workshop presentation. Alex Ravnik will do prompt 1 on risk modeling. Jared Hennon will do prompt 2 on the inspections. I will take care of prompt 3 on measuring effectiveness. And Tom Chow will address the failure rate analysis prompt. And then between the 4 of us, we'll handle all questions. Alexis, you go ahead and want to go to the next slide.
Okay, thank you very much, Paul. So this is a restatement of prompt 1. Everybody's had a little bit of a break, so to refresh your memories, prompt 1 was about explaining the major changes in our risk model since the 2023-2025 base WMP, and especially the drivers for these changes and how they impacted our wildfire mitigation strategies. So if you could go to the next slide. One of the major changes that we've done with our risk modeling is a transition from the National Fire Danger Rating System to a Fire Potential Index, which is a program implemented by TechnoSilva. The National Fire Danger Rating System, while a very useful high-level forecast generated by the federal government, has some limitations, which is why we've wanted to transition away from it. For starters, our entire system was in the singular service area SC10, which made granularity difficult and meant that we could not respond flexibly if it was a particularly high-risk day, Brown, for example. That was all we had. Our entire service territory would be Brown. And only a single report was generated per day, so we could not tailor our needs to any particular moments in time or focus on the high-risk portions of the day, which meant that we would lose an entire day of work. In addition, it was just somewhat sensitive to political issues, such as government shutdowns, which come by every now and then, and we wouldn't be able to do wildfire modeling on those days while we were using the National Fire Danger Rating System, which is, of course, a risk that we want to move away from, which is why we've started implementing the Fire Potential Index from TechnoSilva, as it is much more granular and is tailored directly to our service territory to meet our needs. This allows us to have much more targeted wildfire prevention measures, such as PSPSs, which improves our reliability and our efficiency. In addition, these reports are generated every 3 hours, allowing for more temporal granularity as well, and gives us a better estimate for customer notifications and similar planning protocols. These data are generated by TechnoSilva for us with a greater than 98% uptime, which means that we're just much more resilient to fluctuations beyond our control relating to our ability to do wildfire prediction. So if you go to the next slide, this is just a little bit of an overview of some of the benefits of FPI and our particular implementation of it. Most notably, this is just a particular example of one of those calculations for our service territory. We run this daily in-house, pulling from the TechnoSilva databases as part of our updated PSPS procedures, and a high fire potential index. This is not a high fire potential index. That would be with like orange or red hexagons, can trigger PSPS considerations and additional subject matter expert review. Notably, we want to cover a much wider area than only our service territory, which is that little mass of green and blue in the center, which is where our lines are. This allows us to take into account effects that such as fire propagation and spread that might affect other places beyond our service territory. And sorry about that. And if we go to the next slide, which is a little bit more zoomed in, we can see that areas of high risk, which are, again, like I mentioned before, those warmer colors, can potentially overlap with a high FPI. And that gives us a much more clear understanding of which circuits we want to target for wildfire prevention measures. So in this particular example, we can see that that circuit on the upper right, which is our Pioneer circuit, is somewhat higher risk, but because the fire potential index for that area for this particular day was low, it gives us a more clarity about the potentials for fire and the kinds of risks that we need to take into consideration when doing subject matter expert review to determine any particular wildfire procedures for the day. Implementation of this and transition away from NFDRS was one of the main things that changed regarding our TechnoSilva fire models from the base WMP for 2023 to 2025. But if we move to the next slide, we can see another model that we've been working on in building up, which is this utility risk model that we've contracted Direxion for. In the past, we were utilizing this fire safety circuit matrix living document, which, while very useful, had a number of limitations regarding the ways in which it prioritized bare wire mileage and consequence determined solely by fire risk without consideration of additional impacts like customer uptime, reliability, financial costs, or environmental impacts. Especially as we have been covering more and more of our circuits, the fire safety circuit matrix is becoming less able to fully predict behavior as some of these events that were dominated by the bare wire mileage are becoming more dominant as the bare wire mileage is reduced. So we want to explore these additional risk drivers and get a deeper understanding of consequences, as well as build a more consistent model that is less subject to SME review and instead is a little bit more objective. To that end, we contracted Direxion Solutions to build this model of all of our assets and calculate risk at the asset level in this uniform way. In addition, we can consider additional drivers such as asset degradation and vegetation growth beyond just the bare wire mileage. In this model, we combine fire likelihood, fire consequence, PSPS likelihood, PSPS consequence, and financial costs into a singular utility risk value that we can work to optimize year over year and view long-term effects to improve our long-term planning strategies. Alternately, we can instead choose to view it just at an asset level to examine circuit level risk values for a particular time period. So it's a very flexible model that we can then review to give us further predictive power and make our jobs easier and our predictions more accurate. So if you go to the next slide, this is just an example of the results of one of those simulations on the next slide. Yep. This particular example is an overview of the probability of failure for a given pole, as well as the aggregated utility risk for a given circuit for the year of 2025. These numbers are unitless. They're not, unfortunately, they do not yet have a particular percentage associated with them. That is another improvement that we are looking into, but have not yet made on this model. But as you can see, certain areas are inherently higher risk and give us a point to focus on for improvements. This focus on particular areas for improvement gives us short-term risk assessment planning. But if we look at that chart on the right, those two charts on the right, we can see how risk spend efficiency is aggregated over our entire system, as well as a total utility risk year by year. And so if we move to the next slide, this is a snapshot from 2035, one slide back. There we are. This is a prediction for if we follow the recommendations of the model and our current plans and long-term goals, our risk values will have decreased in accordance with these graphs over just a relatively short 10-year time. We can see that the blue strategy on that upper right chart, which is our current strategy of implementing covered conductor, over that 10-year span is the cheapest way to reduce risk the most. And our overall utility risk is driven down significantly compared to the green strategy, which is just following GO 165 requirements. So, and this gives us a much better understanding of why we would want to implement this strategy and a tailor-made way of how to implement it so that we can successfully drive down risk and reduce the probability of wildfires. So if we go to our very last slide, or the next slide, which is a long-term simulation out to 2074, we can see that risk is drastically reduced. And this is just a final statement, although obviously we do not want to use this far out as our sole predictive measure. Thank you so much. These were the two major implementations or updates to our modeling that we have done. I am going to be handing the presentation off to my colleague, Jared Hennon, for prompt 2.
Jared, if you're speaking, I believe your microphone's muted. Jared, are you able to hear us? I believe your microphone is still muted.
He said he can't unmute.
He said he can't unmute?
Yeah, on his end.
Rain, from our end, to me, it doesn't look like he's muted. Is that your understanding as well?
From my end, it shows that his mic is muted.
Okay.
He should be able to just unmute it.
Hmm. Jared, it looks like you also might be in this meeting twice. I don't know if that's affecting your microphone at all. But from our end, we are unable to mute or unmute you. Until we get this solved, do you mind if from the Bear Valley team, if we switch to prompt 3 for now and then go back to prompt 2?
Yeah, that's fine for me.
Okay. All right. And then when you finish, we'll circle back to Jared and see if his microphone issue is resolved.
Okay, here we're looking at the methodology that Bear Valley uses to determine and measure the effectiveness of wildfire mitigation initiatives and activities, and then how combined effectiveness of initiatives activities is determined. So unfortunately, there's no effectiveness meter. And in general, there's a wide variety of different types of mitigations. So I'll go through various ways of doing this, but overall, what we're mainly focused on, obviously, is the wildfires caused by the utility, ignitions, and then how much are we having to rely on PSPS in order to avoid high risk events. And so, for Bear Valley, fortunately, we've had pretty reasonable results. We look closely at ignitions. We're obviously very focused on that. And then also at PSPS, we train very hard. I look very closely at invoking a PSPS should we need to, but thus far we haven't, fortunately. Go to the next slide. So one of the things we can look at is models. Now, obviously, models are just a it's taking the inputs that we fed it. But if we look at Firesite from Technosilva, used to be called Worm. You can see up in the upper left, that's what it was in 2019, running it unmitigated. In other words, before we had really implemented some of our grid hardening initiatives. And then in February of 2025, the one in the lower right, lower right is mitigated for the subtransmission system. So you can see, from the model's perspective, it shows an effectiveness. We also, and granted, some of these models draw from the same databases, but we look at FPI, not the FPI itself, but the fire behavior index of the circuit on the circuits themselves. How likely is a circuit going to have an ignition on a daily basis? So I think Alexis showed you that overlaid on the FPI chart. The early on when we were doing that, we saw areas that were culprits, were higher risk of ignition. And so we go after those areas, and the models now seem to show that they have lower risk. If we go to the next slide. So this is the same image, only for distribution. So we're looking at the unmitigated, and I say unmitigated, the baseline when we started most of our wildfire mitigation initiatives using the wildfire mitigation planning process. Obviously, we've been doing wildfire mitigation for a long time, but well before this. But you can see on the distribution system where it is today. That was February of 2025 in the lower right. So improvements have been made, but there are areas that we're really targeting in this next WMP, the 2026 to 2028. Go to the next one. So Alexis mentioned this one. We're moving away from this model, but you can see this is the fire safety matrix model that we had. It was kind of it's more of it's a mix of calculations and subject matter expert inputs. You can see there's been a steady risk reduction. A lot of that, this model tends to be driven by the amount of bare wire in the system. Go to the next slide. So other effectiveness measures, not all measures are aimed at preventing ignition. For example, we have outreach initiatives for PSPS and wildfire mitigation. And so customer and stakeholder surveys, we do those semi-annually. Are we getting is our customer base understanding what's going on? Are they getting the message? We also looked at the independent evaluator report in detail. Those come out. We've over the years have made, taken on board the independent evaluators, address a lot of issues regarding the quality assurance area, and we've been working to improve in that area. And so we look closely at the independent evaluator report that gives you, and they look at every single initiative from how much you spent, how well you did in budgeting, and then were the targets achieved, and what was the initiative? What did you do? What you said you were going to do? So I think that's a good measure to look at. We obviously, like all the other IOUs, submit quarterly data reports, and those reports are useful. Not just for energy safety, but they're also useful for the utility itself. We can look at how we're doing. We look at other utilities' quality data reports and see where people are headed. So there's a lot of good information there that you can use in measuring effectiveness. We also, in preparing this WMP, did a deep dive in the ignition risks database that the CPUC maintains. And we also did a deep dive in our outage logs, going back pretty far. I think we went back to 2005. One of the things that I'm looking at is more, as a future analysis, we're beginning to see, just as a data point, right now our SAIDI, the sustained average interruption duration index, is less than 3 for 2025. I don't, if you, I've never seen it that low coming out of a winter. I mean, we're in May, and so just for reference, typically that thing's up around, by at this point in the year, that thing's up around 50 or 60. Last year, I think our SAIDI ended up around 60 minutes, which was also fairly low comparatively to other years. So we're seeing less contact events, and I think that has to do with covered conductor and vegetation management. So I think one of the things we want to do is a deeper dive into looking at moderate or higher risk days and then comparing the contact events that occurred and are we mitigating against those contact events. And then as Tom's going to talk about in his presentation, failure events. So you go to the next slide. Okay, that's all I have there.
Okay, Tom, if this is your prompt, why don't you go ahead and get started, and we're still speaking with Jared offline.
Okay. So I'm going to be talking about how do electrical corporation monitors equipment failure and ignition rate, how this data on equipment specs, risk, information in electrical corporation prioritize of maintenance and changes to inspection practices. Next slide, please. So Bear Valley Electric Service started developing our grid automation in 2019, where we're laying down the foundations such as communication protocol, SCADA design, fiber optic communication versus radio communication. Part of that development, Bear Valley ultimately decided to go with fiber optic communication as a backbone to major infrastructure, such as our substation and 34 kV fault location isolated and service reservation system. BVS installed fiber optic cable along the 34 kV sub-transmission line, tapping to each substation back to our SCADA system in our main office. We call it Distribution Management Center. During 2020 to 2021. This allowed BVS to have real-time communication to major infrastructure out in the field. Our fiber system does not cover all other field devices are out on the lines throughout Big Bear area. So in order to communicate with those devices, we also utilize radio communication means to communicate back to our systems, such as 4 kV switches, reclosers, cap banks, trip savers, fall indicator. So in part of the WMP in 2022, BVS started automating 3 substations per year. And by end of this year, we should have all the substation automated into our BVS systems, which allows us to monitor our equipment. And part of the WMP also is we have replaced all our expulsion fuse with current living fuse and electronic fuse like trip saver. As part of last 2023 to 2025 and continuing 2026 to 2027 WP, BVS started replacing aging infrastructure such as switches, field devices, cap banks to automate, and also at that time automate those into the system. In addition, the fuse strip saver that was already been replaced, we started automatically and trip and fall indicator, we are automatic into SCADA system. And part of during 2020 to 2022 WMB period, we also have completed upgraded 2 existing substation. As you can see on our slide, it's a picture of our SCADA system on the 34 kV, and a lot of those, right, that's our current, what it looks like, and devices that we have automated into a system and substation. And then that's another picture of the cap bank where we have replaced, stay on the slide. So, and currently right now, BVS is in the process of upgrading 2 substations, adding a new substation this year, which will also be automated into a substation. And then part of the 2026 of our WMP, we're planning to upgrade 2 more substations. So we're getting everything online, and that's part of how we are monitoring our equipment and preventing. And we also implemented a QC process of our equipment that arrive from manufacturer, where BVS is not just completing a visual inspection, but we also contracted contractor to complete an acceptance test on equipment before installing in the field. That will also mitigate equipment failure. And we would have to start with the baseline of those equipment. So, and also in 2020, BVS established an annual substation test protocol, which BVS contractor assists us in testing 3 substations per year to ensure our substation condition are up to standard, and reports, which allows us to benchmark on our equipment life expectancy and allowing BVS to plan and schedule work to resolve issues or replace equipment as needed. So BVS SCADA system not just monitor at the substation level, also at the circuit level and at the field equipment level, which provides status. We're able to operate commands. It also provide notifications such as faults, trip, and other issue, and keeps historic data of equipment in areas that we have on SCADA. Those all help with monitoring our equipment failure. Next slide. So some of the other programs that we have are inspection programs, where we do the detail, patrol, intrusive, and substation inspection, which allows us to have visual inspection of our infrastructure, such as, but not limited to, the following, like damages, oil leak, bulging, capacitor, blown fuse, arrestor, foreign objects, that kind of stuff. Those are all good. We also had hired a third-party inspector to also do our patrol inspection. This way we have another set of eyes to do checks for us. Other than that, we also have inspections that we are conducted by contractor that utilize drones, which provides thermographic and HD camera, video photography. These photos are very useful because when you're doing a detail or patrol or even intrusive, when you're down at the ground level, you're not going to be able to see the equipment status from the top view. So those inspections are very useful from the high level down, and that would also help us with monitor equipment failure. And then part of the contractor, they evaluate all the photos and provide findings to us for review. And like after reviewing our reviewing process, BVS would plan to schedule and resolve any potential issues. Next slide. So Alexis has talked about Direction. So we, like we said, so in 2024, we engaged Direction to develop our utility risk model that evaluates ignition risk and PSPS risk by drawing inputs like from TechnoSilva modeling, providing them with our asset database, inspection results, and customer information. Direction model will assist us not just also evaluate costs in related to risk reduction, as well as evaluate alternative mitigation strategies, help us optimize long-term strategy plan to reduce wildfire risk. BVS is still in developing with direction on team to improve and make adjustment to our risk model. Once BVS implement this risk model, it will enable BVS to make better decision making based on data driven, all that stuff. For example, like this is kind of going over what Alexis kind of talked about, where at the circuit level, it shows that there's a red area, which is one of our circuit, which is higher risk compared to yellow area, which is a medium risk, versus green risk is lower risk. So with direction on data provided, we would want to focus on the red area. We would evaluate their plan and their data to schedule hardening systems such as cover conductor, pole replacement, also including aging infrastructures, equipment on the pole, and to mitigate ignition risks. Next slide. So other monitoring methodology that Paul has talked about is we do utilize our outage log, and we keep track of our outage caused by different various categories such as lightning, equipment failure, vegetation contact by objects, etc. When BVS has an outage, BVS evaluates an outage situation to see what happened and how we can prevent this from happening again, and to improve system reliability, reduce outage, and prevent equipment failure. If it was an equipment failure, BVS team would evaluate the situation, take the equipment off, and then see what we come up with. And we would work with manufacturers to see if they have encountered this at a different utility, and what's the next step to mitigate this from happening again, such as change out the similar equipment and to prevent this from happening. BVS also utilized CPUC ignition data to evaluate the different types of ignition costs that other utilities has encountered, where BVS can learn and improve our system to mitigate ignition risks. So part of the CPUC ignition data, I guess one suggestion was to maybe have more details of what type of equipment failure that has occurred. And then this database would definitely be helpful for all different utilities, and that would be useful to monitor equipment failure and reduce the ignition rate. With all this improvement project inspections, direction and modeling, and database that has been integrated throughout the years, BVS has a support system that monitors equipment failure as it or issue as it arose, and a database that we continue to gather, and we'll make adjustment to our project and inspection programs to ensure we mitigate ignition and risk. BVS is always looking into new technology and methodology and working with other utilities that we all face to mitigate ignition and risk and prevent forest fire, wildfire. That's all I have. Thank you.
All right, thanks very much, Tom. Let's go back to Johan. Let's go back to prompt 2. And while we're doing that, Jared, can you see if your microphone's working now?
Yeah, can you hear me?
I can. Success. Okay, perfect. Please go ahead and proceed with your presentation.
So prompt 2 for us is describe the electrical corporation's detailed asset inspection process for transmission and distribution. At Bear Valley, we do not have any transmission lines. All these slides will be just for our distribution. And then, so we'll discuss how our inspection intervals determined, and then how our findings integrated into operational decisions. You go to the next slide. So Tom touched on this a little bit. One of our most useful asset inspections is our UAV photography and videography inspections. And these inspections, will identify damaged assets that you wouldn't be able to see from the ground from a detailed inspection or a patrol inspection or any other kind of inspection. So we do an annual inspection on all of our primary poles. Our whole service territory is located in the HFTD tiers 2 and 3. So all of our assets are considered high fire risk threat. So we do the photography of each pole, and then we also do the thermography to identify any abnormal heat patterns on the equipment. And then we also use all these pole data for engineering rebuilding poles, or if they are curious about what equipment's currently on the pole. A lot of different departments are using these photographs to help with projects and planning and stuff like that. So this is a very helpful one for us. And I believe Tom, you touched on it. It's all conducted by a contractor who comes out and will take pictures of all of our poles. Typically, as soon as the snow melts in the higher peaks of our areas, so late April, they usually try and start so that we can get the data before fire season, the main fire season begins. So they will also do most of the analysis. They will go through the photos and flag anything that seems abnormal. And then internally, once we get all the flagged stuff, we will go through that with our field inspector and identify any abnormal equipment or damaged equipment and fix it appropriately. Next slide, please. The next one is our GEO 165 detail inspections. We're currently on a 5-year cycle of all of our assets, but this year we started a risk-based prioritization of our higher risk circuits. So some of our higher risk circuits will be patrol or detailed inspected more often or earlier in the year to ensure that we're getting eyes on it before the main part of the fire season hits. One of our main vegetation management inspections are LiDAR inspections. So we do a combination of vehicle-mounted LiDAR and drone-mounted LiDAR for areas that are not accessible by road. And again, this is our entire service territory. We do an annual inspection, and it will identify any encroachment to the lines. And if there are trends that are identified, we can switch up our routine vegetation management plan for the following year, along with addressing any findings throughout the entire system. This has been probably our most useful tool for finding vegetation encroachments. And we have definitely seen a fall in vegetation related outages, along with just total vegetation around the lines every year. So it's a very useful program in our arsenal. Next slide, please. Next slide, please. Thank you. Then the next one, we do 2 full patrol inspections of our entire overhead facilities every year. One is internally by our field inspector, and then one is by a third party independent, ground patrol of the entire system. This ensures that we're able to get eyes on every asset an additional 2 times per year. So it's a very useful tool to us. We do have the luxury of having a small service territory compared to the other three utilities on this call. We only have about 205 miles of line, so we are able to look at all of the assets multiple times a year and determine any abnormal or broken equipment and vegetation as well. Next slide, please. Next slide. Thank you. A new one we have is our satellite imaging program. We have a contractor conduct a satellite image of our entire service territory again annually. They also incorporate all of our LiDAR data into their analysis. And they identify a couple of different things for us. They identify potential grow-in risk, fall-in risk, and then dead and dying trees as well. And this really is useful for making our vegetation plan for the next couple of years, along with spot treating areas. So dying trees is a big one for us, of just being able to find them and have potential to hit our lines. And then as well as grow-in risk of such as fast growers, stuff like that. So this has been a useful tool for us as well. And the next slide, please. And our final inspection is just the intrusive pole inspection. And we do about 850 poles a year. That's approximately 10% of our whole entire system. And this is an inspection our contractor does for us, and it identifies any weaknesses through the poles. So the inspection provides a graph that can show how much strength is left in the pole, and these are then sent to our engineering department and analyzed, and then if any poles are failing, obviously will be corrected. And so these are all of the inspection programs that we're going to be using in this next WMP cycle. So thank you very much.
Okay, thanks very much to the 4 presenters from Bear Valley. We now are open for the Q&A for all participants and presenters for Bear Valley. So please feel free to attendees, please feel free to raise your hands or post questions in the chat. Okay, we have our first question from Tyler Dunaway.
Go ahead and unmute yourself, Tyler, and you may speak. All right, looks like Tyler has put his hands down. Next up, we have Greg Morris. Greg, please unmute your mic and you can speak.
Okay.
Greg, you will need to unmute your mic, please.
Yeah, you're unmuted on our end, Greg. What I'm going to suggest is he says he cannot unmute. Rain, can we try unmuting Tyler again and then we can follow up with Greg? Okay, Tyler, you are unmuted on our end. Can you try speaking up? You'll have to unmute your microphone on your computer as well. Okay, we still can't hear you. Would you mind, for Greg and Tyler, would you mind putting your questions in the chat? If you're able to use the chat, and then we can read them out and address them there. If that's the case, let's go to Henry Sweat. It looks like you have your hand raised. Henry, you're unmuted on our end. Please go ahead and unmute yourself on your end.
Can you hear me?
Yes, we can.
I know Tyler's question, so I think I can ask it for him.
Okay.
It's kind of a two-parter. Number one is it correct that BVS has never had an ignition or a CPUC reportable ignition in the past? And if so, like kind of my follow-up question is what data was fed into the Direxion risk model to kind of inform the relative risk of circuits? Thank you.
Alexis, do you want to? It's true we've not had a reportable ignition. That's correct. And Alexis, do you want to take the Direxion piece?
Alexis, if you're speaking, I don't think we can hear you.
Oh, sorry. I'm sorry. I was muted on my end.
Oh,
Can you hear me
okay,
now?
good. Please
Yes.
go ahead and speak.
Yeah. No. While it is true that we have not had a reportable ignition, we do have access to CPUC data regarding ignitions from other utilities, and those data, in combination with TechnoSilva fire risk data, have been fed into the Direxion model to generate these probabilities and risk values. So it may not be fully tailored to our system. It is still based on historic data. Does that make sense? Is that clear? And then I see Greg's noticed that the WMP says that we are transitioning to the Direxion model. That is correct. This is still under development. We have not fully moved away from the fire safety circuit matrix, as Paul noted in his portion.
Okay, Greg, did that answer your question? Oh, it looks like he has a follow-up. Are you already using information from Direxion in the current model or the current WMP?
The current WMP is we are not officially using information from the Direxion model, but we are reviewing it and looking at it going forward and seeing how it compares to our fire site models and fire safety circuit matrix models. So if you look into our WMP, you will see that off the top of my head, I want to say it's table 5-5 or maybe 6-5. There are some tables in there that I don't recall the numbers of exactly, but although those tables do not have the Direxion model in them officially, we are reviewing the Direxion model's current set of outputs and comparing them against these official models when making decisions.
Yeah, let me add, we just received the phase 2 package from Direxion, reviewing it, then we'll be training on it and implementing it.
Thank you.
And then in June, we're working with one of our contractors, I think the Jensen Hughes, coming to visit and developing a phase 3, which implements the protective equipment device settings risk module, which would come out of the Direxion. So that's where we're proceeding with that.
Okay, thanks very much for that response. Does anyone have any other questions for the Bear Valley team? I'll wait a few minutes for hands to raise or questions to pop up in the chat. We do have some time. Okay, we have another follow-up from Henry Sweat. Rain, please go ahead and unmute him.
Go ahead and unmute Henry. You should be able to talk.
Thank you. For the Direxion model, you mentioned that you're getting, I think you said outage data and TechnoSilva data. Is the data that is from TechnoSilva, are you using that for the consequence portion of the equation, or are you using it for also the ignition risk portion of the equation?
Thank you very much, Henry. It is being used in both portions of the model. Some of the ignition risk data are coming from TechnoSilva, but then some of the consequences like acres burned are also from the TechnoSilva model. But other portions, like for example, the PSPS risk, are not related to TechnoSilva data at all.
Okay, for our next question, Greg had another question in the chat, which is how many substations do you have and what % are upgraded to fiber optics?
We currently have 13 substations, and we're down to, oh, well, they all have fiber optic going to it, but this year we're down to the 2 new ones and the one that we're rebuilding. Then we'll be all on SCADA.
Okay. Tyler Dunaway has another question stating, I have a question regarding Bear Valley's 2025 SAIDI score. I know that Paul stated that the SAIDI score is low, like 3 for 2025. Given that Bear Valley hasn't had any initiated PSPS events, have you been impacted by PSPS events triggered by SCE along the 3 SCE supply lines?
Yes. So in January, Edison did de-energize some lines, and that did impact us. Just in when I mentioned the SAIDI, because that's a loss of supply, it's not calculated in the SAIDI. But we were impacted by an event, I believe it was on January 25th, I think. It was a Saturday, a long Saturday. But yeah,
Okay.
we are impacted by Edison lines. In fact, we coordinate very closely with Edison. In fact, myself and another 7 folks from our team are visiting Edison tomorrow at their emergency operations center to make sure we coordinate very well with them this next season and build upon that.
Okay, thanks, Paul. Henry, it looks like you have a follow-up question. Please go ahead and unmute yourself.
So with regards to the PSPS event on January 25th, my recollection was that you guys have a generation facility that you guys can turn on at like really, really quickly. And so I previously kind of remembered that the thought was that the risk of the supply being cut off might not be so large because you could turn on that generation facility. So I'm wondering if that generation facility was used during that event, or if not, why not?
Great question. So that generation facility was used. In the winter, we do have a higher load, and that generation facility is, I think it's 8.4 megawatt output. So it's our load is higher than 8.4, so we had to do some rolling blackouts for residential. We were able to maintain critical infrastructure and commercial infrastructure up. And the other issue with the generator plant, it's a peaker plant. It's not a base load plant, and so it doesn't handle. It's very tricky to maintain stability. I'll just say that because if you have a load change, it doesn't accommodate load changes very well. Basically, anticipate very carefully. So, but we made it through that. We do have some initiatives in this WMP where we're installing a solar generation facility and a battery. And I think it's our estimates that with the solar generation, the battery, and the power plant, we can essentially go into an island mode and carry our loads. And the battery would offer a lot more stability to the peaker plant. As load changes, the battery can accommodate those load changes and soften the way the plant responds.
Thank you.
Thanks very much for your question and response. Does anyone have any other questions for Bear Valley? We have a few minutes left for them. Just wait for another minute or two here. Okay, I think that's it for questions. So next up is our lunch break, which I'm sure everyone is looking forward to. Let's all come back at 1 o'clock, where we will switch to the SDG presentation. So thanks very much to the Bear Valley team. Also, as a quick reminder to the Bear Valley team, please make at least one of your presenters available to ask any or answer any questions that will happen at the end from our 3:50 to 4:30 open Q&A session. But thanks very much for your help. And we will see everyone back at 1. Rain, can we please pause recording for the extension of the lunch break?